Hello dear learners. In this video session, we are going to study about elementary operations and inverse of a matrix. Learning objectives of this video are, at the end of this video session, you will be able to apply elementary transformations on matrices. You will be able to determine inverse of a matrix by using these operations. Elementary operations are, basically there are 6 elementary operations. 3 are arising due to rows and 3 are due to columns. So first is interchange of any 2 rows or columns. This is denoted by Ri changes to Rj. You can check this notation, basically double-headed arrow. So this says that Ri and Rj are going to be interchanged. Similarly, columns I and J are also going to be interchanged. For example, this matrix A, if you wish to interchange first 2 rows, row 1 and row 2, so that can be denoted by that, and you can see here 4, 5, 6, R2 over there has been changed as R1 here, and 1, 2, 3, R1 has been made R2 here. So second operation is multiplication of elements of any row or column by a non-zero scalar. This is represented as Ri changes to K times Ri. K is non-zero scalar. The same can be done with columns as well. So for this matrix A, if you are interested in changing R1 to A times R1, so this is written as this: R1 changes to A times R1, and elements of the first row, they are written as A, 2A and 3A. The addition to the elements of any row or column, the corresponding element of other row or column is multiplied by non-zero number. This is written as Ri changes to Ri plus K times Rj. This means if you are interested in changing this C2, then start by writing C2 minus 3 times C1. How this is done? This is C2. So you are going to make changes in C2. So this 3 minus 3 times C1, 3 minus 3 into 1, that is giving you 0. Then 4 minus 3 times 2, that will give you this element minus 2. So C2 has been changed by using this elementary operation. So now let's learn what are invertible matrices. If two square matrices A and B of the same order are such that A into B is equal to I means identity matrix of the same order is equal to BA, then B is called inverse of the matrix A, and this is denoted by A inverse. Also A is called invertible matrix. For example, let this matrix A and this is matrix B. You multiply AB, we are getting identity matrix. You multiply BA, we are again getting identity matrix. So A inverse is equal to B and B inverse is equal to A. So let's learn a few results on invertible matrices. Inverse of a square matrix, if it exists, it is unique. That means whatever method you are going to use, whatever method I am going to use, the inverse is going to be same. For example, A be an invertible matrix, let B and C be two inverses for the same matrix A. In that case, by definition, we must have AB is equal to I, that's equal to BA as well as AC is equal to identity matrix. Let's compare these two equations. Let's start with B. So you multiply any matrix with identity matrix, write it as BI. In place of I, substitute this AC or CA. So we have substituted I as AC. So then take BA and multiply it by C. This BA will become IC, and finally you are getting only matrix C. So B is equal to C. That means inverse of the matrix is always unique. Result 2. This is very important result. If A and B are two invertible matrices of the same order, then AB whole inverse is equal to B inverse into A inverse. This is also called law of reversal. That means order of matrices A and B is going to be interchanged. So let's prove this. From the definition, we know that AB multiplied by its inverse must be giving me identity matrix. So pre-multiplying, that means multiply each term by A inverse. Write A inverse here as well as here. Start multiplying term wise. A inverse into A, that will give us identity matrix. Write this B here, write this AB inverse here. A inverse I is giving you A inverse only. A inverse A is identity matrix, that is being multiplied by B. Then AB inverse at its place, A inverse there. This IB is again giving you B, so AB whole inverse. This is equal to A inverse. Now again pre-multiply both the sides by B inverse. So B inverse into B will give you I, AB inverse at its place, and this is B inverse A inverse. So in turn you are getting AB whole inverse is equal to B inverse into A inverse. So inverse of a matrix by elementary operations. What should be the steps to be used? If we have to determine A inverse by row operations, then you start by writing A is equal to IA. Apply series of row operations only, and then you will get B is equal to A inverse. To determine A inverse by column operations, in that case you have to start by writing A is equal to AI. Then apply series of column operations only until you get I is equal to AB, and in turn B will become equal to A inverse. Why we are changing it? A is equal to IA. In that case, for this matrix I, rows are used. That is why for row operation we are supposed to write in this manner. Then in this case, if we actually multiply A and I, then for matrix I we use columns, and that is why we are writing in this manner for column operations only. Let's do few examples from NCERT. This is question number 1 from exercise 3.4 of NCERT. You are given second order matrix A. You have to find its inverse by using row operations. So how will you going to start? You write A is equal to IA. This A is going to be written as it is throughout the question. You are going to make changes here in this A as well as this matrix I. So write them, substitute value of A here, substitute value of identity matrix, and please make it sure that identity matrix is going to be of the same order. Then apply R2 changes to minus R2 minus 2R1. Why so? Because your very first step is to make this element 1, which is already there. So one step is already done. Then we have to make this element 2 as 0. So for that we are writing 2 minus 2 times 1. That is how this operation has been used. So this becomes 0 here, 3 minus 2 into minus 1. So that is making 3 plus 2, 5. The same changes have to be made in this R2 here. 0 minus 2 is giving you minus 2. 1 minus 0 is giving you 1. So let's proceed further. The next step is to make this element A2 2 as 1. For making so, we have to divide this row by 5. So we can write it as R2 changes to 1 by 5 R2. So this becomes 1 here, this becomes minus 2 by 5, and this one changes to 1 upon 5. And next step is that this was the matrix in the previous step. So then you apply R1 changes to R1 plus R2. Why so? Because I need to make this element minus 1 as 0. So I am adding these two elements. So this becomes 1, 0, 0, 1 and change here 1 minus 2 by 5. That's giving you 3 by 5. 0 plus 1 by 5, that will give you 1 by 5. So you can see here, this is identity matrix I. This matrix has been obtained and this is A going on. So this blank space, this matrix which you have obtained by row operations is nothing but A inverse. Thus this matrix is A inverse. Moving further to next question of second order matrix only, but now this time we are going to use column operations. So just make it sure that throughout the question we are going to use only column operations. So how we have to start? We'll start by writing A is equal to A times I. Again, like in the previous question, this A is going to be written throughout in this manner only. So write A here, whatever the question has been given to you. The identity matrix I has been written. It is also of the same order 2. Then apply. C1 changes to C2. Why am I choosing this operation only? Because my very first step is to make this element 2 as 1. So for that we are interchanging both the columns. So 1 1 has been made column 1, 2 1 has been made column 2. The same operation has to be applied here. This 0 1 has been written here and this 1 0 has been made as column 2. After that, our next step is to make this element 2 as 0. For that, we have to apply C2 changes to C2 minus 2 times C1. So for that, 2 minus 2, 0, 1 minus 2 will give you minus 1. The same will be changed here. 1 minus 0, 1, 0 minus 2 will give you minus 2. Let's move to the next step. So you are getting this as the last step in the previous slide. So applying C2 changes to minus C2. Why so? Because I need to make this element as 1 like this. So we are multiplying column 2 by negative number 1. So same changes have to be made here. 1, it becomes minus 1 and it becomes plus 2 here. Then applying C1 changes to C1 minus C2. That means this becomes 1 minus 0. This becomes 1 minus 1. So in turn you are getting identity matrix here. The same thing is happening here. 0 plus 1, 1 minus 2. So this is going to be our answer and this is our A inverse. Moving further to next question of third order matrix. So you can use elementary operation. In the question it will be mentioned using elementary operations. It is your task, it is your convenience that what you wish to use, row operations or column operations. So if I am using row operations, that means I need to write in this manner. I need to start like A is equal to I times A. Write A, write identity matrix and this second A will be written as it is. So what you are going to do? Make this element A11 as 1. For that we can change R3 and R1. Why so? So that I am getting a larger number here than this number and I will subtract in the next step. That is like here. So this was the previous step. Applying R1 changes to R1 minus R2. So 3 minus 2 will give you 1. Minus 2 will give you minus 4. 2 minus 3 is giving you minus 1. The same changes here. 0 minus 0, 0. 0 minus 1, minus 1. 1 minus 0, it's giving you 1. So first step has been done by making A11 0. The next step involves that you have to make these two elements A21 and A31 as 0. For that what you have to do? R2 changes to R2 minus 2R1. R3 changes to R3 minus 2R1. You have to focus on these two elements only. By applying these operations, you are getting these elements 0 and accordingly you are going to change R2 and R3 here. Let's move further. That is a previous step. So now what is the next step? Make this element A22. as 1. For that we are going to divide R2 on both the sides by 10. So this becomes 0 only, this becomes 1. 5 by 10 will give you 1 by 2. The same is happening here, 0, 3 by 10 minus 2 by 10, that will give you minus 1 by 5. The next step is that this element A12 and A32, these two elements have to be made 0. So focus on these elements. Minus 4 plus 4 times 1, that means it's written as R1 changes to R1 plus 4 times R2. Similarly, this 5 is to be made 0. So 5 minus 5 times 1, which is written as R3 changes to R3 minus 5 times R2. Make changes here, it becomes 0. You can see in the previous step we have obtained these two zeros. By using these operations, these zeros and this one is intact. So only this column is going to be changed. After that, make same changes here in these R1 and R3. So this R1 and R3 is also going to be changed by using the same two operations. Let's move further to the next step. This is the previous step. The next step is to make this element 5 by 2 as 1. For that, we are going to multiply this row 3 by 2 by 5, so that this element becomes 1. This elements become 2 by 5, 1 by 5, minus 2 by 5 respectively. After that, next step is to make this one 0 and make this half also 0. 1 minus 1 will give me 0. That means R1 changes to R1 minus R3. Then 1 by 2 is also to be made 0. For that you can write R2 changes to R2 minus half R3. Apply these operations, you are getting 0 here, 0 and 1. You can see the other two 1s and 0s are intact. Same changes have to be made here. R1 minus R3, 0 minus 2 by 5, 1 by 5 minus 1 by 5, 1 by 5 minus of minus 2 by 5 is giving you 3 by 5. Then change R2, 0 minus 1 by 2, 2 by 5 is giving you 1 by 5. 3 by 10 minus half times 1 by 5 is giving you 1 by 5 only. Minus 1 by 5 minus half is giving you minus half times minus 2 by 5 will give you minus 2 by 5. So our question is almost done. So we have got inverse. Let's summarize. There are 6 elementary operations, 3 are due to columns and 3 are due to rows. Interchange any two rows or columns that can be represented as Ci changes to Cj. Multiplication of elements of any rows or columns by non-zero scalar quantity is represented in this manner. Then addition to the elements of any two row or column to the corresponding element of any other row is represented by Ci changes to Ci plus k times Cj. So this was all about elementary transformations. In this video session, we have learned how to calculate A inverse by using elementary transformations. In the next video session, we will continue this concept by using determinants, how to find A inverse by using one more method by finding adjoint, and then we will use these matrices, these concepts by using determinants, by using matrix method. Then how can we solve these matrices and determinants to solve system of equations? That is very major application of matrices and determinants. Thank you everyone.